Hello! Alright, so the purpose of this video is to show you how to solve quadratic equations with imaginary solutions. Okay, so you might remember, so recall that an equation of the form ax squared plus bx plus c equals 0 can be used by using the quadratic formula. And this quadratic formula is shown right here. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And for imaginary solutions, like it showed you in the last assignment, imaginary solutions can be represented with an I, and I equals the square root of -1. Okay, let's do an example so you can kind of see how this works. Okay, so let's say I give you something like this. So our example that I have is x squared minus 4x equals -29. Okay, so what I see here is what we want to do is we want to try to get our equation in the form ax squared plus bx plus c equals 0, right? So in order to do that, what I see first, what we can do is we can add 29. So we can add 29 to both sides here. So this cancels, and then we get x squared minus 4x plus 29 equals 0. Okay, next what we need to do is we need to identify a, b, and c. A is 1, b is -4, c is 29. Now let's go ahead and apply that lovely quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's go ahead and simplify this. Two negatives here become positive, so we have positive 4 plus or minus square root of -4 squared. So -4 times -4 is going to be a positive 16. So we have a positive 16 right here. Then we're going to subtract. So we have 4 times 1 is 4. And then we have 29 times 4. 29 times 4 looks like it's going to be 116. So what we're going to do is we're going to replace 116 here. So 1, 1, 6. And then we're going to divide this by 2 times 1, and that's 2. Okay, now what we want to do is we want to go ahead and simplify it in the square root. So we have x equals, so 4 plus or minus square root of, so 16 minus 116 is going to be -100. And then we divide this by 2. Okay, so like mentioned in the previous class, right? So anytime we have a negative square root, you can think of it as x equals. So we have 4 plus or minus, and then we have square root of -1 times square root of 100, and we divide that by 2. So if you guys have seen a pattern from the previous video, like I mentioned on over here as well, right? I equals the square root of -1. So if we know that I equals the square root of -1, we're going to apply this rule. This part here is I, if that makes sense. Okay, so let's go ahead and apply that. So we have x equals 4 plus or minus I times square root of 100 divided by 2. Now that's a lovely thing about having the plus minus in front here. Whenever we take the square root of -1 that you see here, we don't need to put the plus minus in front. It's already taken care of when we use quadratic formula. Alright, so let me just make some room here, just running out of room. So we don't need some of these things here. Okay, so coming back up, so I'm going to finish off the problem here. Square root of 100. If you guys don't know what the square root of 100, square root of 100 is 10, right? So we get x equals 4 plus or minus I times 10, and then we divide that by 2. In other words, we can also flip this, the order of these numbers around. By doing so, we get x equals 4 plus or minus 10 times I divided by 2. Now what we want to do is we want to divide the 2 into each of the numbers here and here. So x equals 4 divided by 2 plus or minus 10 over 2i. Okay, now what I see what we can do is we can reduce this. So 4 divided by 2 is 2. 10 divided by 2 is 5. So what this means is our two possible imaginary solutions that come out of this is going to be x equals 2 plus 5i. That's one of them. Or we get x equals 2 minus 5i. And there we go. And that would be our second imaginary solution. Okay, so that would be how you would, that's the problem statement. If we were to solve for x, that is how we would solve for x, if that makes sense. Okay, I'm going to show you two more problems. I'm going to go ahead and clear the screen. Clearing. Okay, so let's say give you something like this. So our example is something like 6x squared plus 2x plus 3 equals 0. Okay, same idea. We need to identify A, B, and C. A is 6, B is 2, C is 3. Now we're going to apply a lovely quadratic formula. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. There we go. So x equals negative 2 plus or minus square root of 2 squared. 2 times 2 is 4. 4 times 6 is 24. 24 times 3 is going to be 72. So we have a 72 right here. Then we divide this by 2 times 6. And that's going to be 12. Okay, so next what I see here, we have 4 minus 72. 4 minus 72 is going to be a negative 68. We divide that by 12. Alright, so now what we want to do is we want to put this in simplest radical form. So, but before we do, I see we have a negative inside the square root. So anytime that we have a negative inside the square root here, this is negative 2 plus or minus the square root of negative 1 times the square root of 68. And then we divide that by 12. Okay. Now, like I mentioned earlier, right? The rule here, I equals the square root of negative 1. This part here is I. Okay, so let's go ahead and replace it. X equals, so negative 2 plus or minus I times the square root of 68. And then we divide by 12. Okay, next what I see what we can do is we can break up 68, because 68 is not in simplest radical form. 68 breaks down into 4 and 17. 4 breaks down into 2 and 2. So we have the square root of 68 equals the square root of 2 times 2 times 17. Now we're looking for partners in crime. So here are two partners in crime. One gets shot, one comes out. So we get 2 times the square root of 17. So what this means is, so when we get this here, so this square root of 68 is the same thing as 2 times the square root of 17. Okay, do not forget that. I just need to make a little bit of space here. Okay, so what I am going to do, rewrite this all the way back up here. Bring it back up. So we get x equals negative 2 plus or minus I times, we're going to replace this expression with square root of 68. So we have 2 times the square root of 17. And then we divide this by 12. Okay, making a little bit more space here. So what I see next we can do is we're going to change the order of this. We're going to put the 2 in front of, the I in front of the 2. So we get x equals negative 2 plus or minus 2 times I times square root of 17 divided by 12. Next, what I see what we can do is we can divide the 12 into each numbers here. So we get x equals, so negative 2 divided by 12 plus or minus 2 I times the square root of 17 divided by 12. Okay, and then what I see next is that 2 over 12 can reduce to 1 over 6, and this 2 over 12 can also reduce to 1 over 6. Okay, so what we have is, if I reduce this, we get x equals, so negative 1 over 6 plus or minus, and then we have I times the square root of 17 divided by 6. Okay, I'm going to erase some of the things here. I don't think we need any of these things here, so I'm just going to go ahead and erase. Okay, so now that we've gotten here, okay, so just making a little bit more space here. It's good practice that you put the I in front of the rational expression. So you can just put the I in front. So I'm just going to do that. X equals negative 1 over 6 plus or minus square root of 17 divided by 6. And again, what we're doing is we're going to put the I right in front. So we have an I. So this means that our two imaginary solutions that come out of this are going to be X equals, so negative 1 over 6 plus the square root of 17 divided by 6I. Or we get X equals negative 1 over 6 minus the square root of 17 divided by 6I. So these are two possible imaginary solutions that come out of this. Okay, so it's going to look something like this. Okay, right, I'm going to show you one more example and then I'm going to finish the video. Okay, clearing the screen. Okay, so let's say I give you something like this. Last example looks something like 5x squared minus 3x plus 1 equals 0. Okay, so again, we have something of this form. We're going to use the quadratic formula right off the bat. A is 5, B is negative 3, C is 1. So we're going to go ahead and use that lovely quadratic formula. X equals negative B plus or minus square root of B squared minus 4AC divide by 2A is what Mr. Chang sings. These are a few of my favorite things. Minus 4 times 5 is going to be 20, and 5 times 1 is 20. Divide by 2 times 5, and that's going to be 10. Okay? Next, what I see is we can simplify this, 9 minus 20. So x equals, so 3 plus or minus square root of negative 11 divided by 10. Again, break this up. We know from here, right, I equals the square root of negative 1. So we know that we have 3 plus or minus the square root of negative 1 times the square root of 11 divided by 10. And we know that this part here, this is I. Okay, so by doing so, we have 3 plus or minus I times the square root of 11 divided by 10. We're going to finish this up on the left hand side here. So left hand side here, we're going to break this up, divide the 10 through. So x equals 3 divided by 10 plus or minus I times square root of 11 divided by 10. And like I mentioned earlier, it's good practice to put this I in front of the rational expression. Okay, so when we put it in front of the rational expression, we get x equals 3 divided by 10 plus or minus square root of 11 divided by 10 times I, which means our two imaginary solutions, our final answer is going to be x equals 3 divided by 10 plus square root of 11 divided by 10i, or we get x equals 3 divided by 10 minus square root of 11 divided by 10i. And there we go. So it looks something like this. All right. Please let me know if you have any questions on this. Okay. Bye.